Everyone, so this is the question asked in gate EC 2008 and it is of two parts. We have to calculate DC current IE and the mid-band voltage gain of this amplifier. So first of all, we know that it is an NPN transistor because emitter is grounded, input is applied to the base and current always flow from P to N. So this is basically NPN, common emitter follower. So it is a common emitter amplifier, okay, in which emitter is common, input is applied to base, output is taken from collector terminal, and we have this supply voltage 9 volt VCC and this is ground. Okay, so let us just start our DC analysis. So how to do DC analysis? Okay, so we open all the capacitor and open circuit all the capacitor and we take the DC voltage VCC. Okay, so VCC is actually 9 volt. Now this is our collector resistance. Also you need to apply because this is, suppose this is R1 and this is R2, so you need to calculate the equivalent Thevenin circuit in which we need to calculate VTH and RTH. So this is VCC 9 volt and this is collector resistance 3 kilo ohm. This is BJT in the DC analysis, and because this capacitor is open circuit, so we have 2.3 kilo ohm emitter resistance here and this is grounded. Okay, and output is here, V output is here. Now you need to calculate VTH and RTH. So how you can calculate that? So VTH is what? We need 9 volt here because Thevenin voltage is here, so 9 total volt divided by 10 plus 20, so this will be equal to 9 into 10 by 30. Okay, so it will be 3, so VTH will be 3 volt, this is 3 volt. And what is RTH? RTH will be R1 parallel R2, but you need to calculate RTH because in the question it is given that beta is very large. Beta is very large. Since beta is very large, you can neglect base current. IB is 0, and if IB is 0, then you can say that IC, this collector current, will be equal to IE because base current is 0 due to large beta. If beta is large, beta is what? Beta is the current gain of this amplifier, common emitter amplifier. So you know that beta is IC by IB. So if beta is very large, IB will be 0 because beta is infinity. Okay, so IB is 0, IC will be equal to IE. So our task is to calculate IC, then we can calculate IE or anything. Now how you can calculate it? Because you are given VBE is 0.7 volt. So yeah, this is base terminal, this is emitter terminal, and the voltage to turn on the transistor, cutoff voltage, is 0.7 volt. You can apply KVL here. So you can apply KVL right now. So it will be 3 minus 0.7. We are not taking this resistance, and minus 2.3 kilo ohm into IE is equal to 0. So 3 minus 0.7, it is 2.3, and it is equal to 2.3 kilo ohm IE. So IE is what? 1 milliampere, right? And the same, IE is equal to IC, so the answer will be A, 1 milliampere. Now what about the second part? The second part asks you about the mid-band voltage gain, and you know that what is the internal voltage gain of a common emitter amplifier? You write internal current gain, and this is a short trick actually. You actually, if you want, you can draw the small signal model of that. In that case, capacitor will be short circuited, but I will tell you the short trick, which is the internal current gain and it is a negative sign because in common emitter there will be 180-degree phase shift. So you take negative sign here, and the internal current gain is beta, which is for this amplifier, and it is divided by internal impedance. So what is the impedance of a common emitter amplifier? It is R pi. If you apply a pi model, you know that the internal impedance is R pi, and it is multiplied by the total load. So what is the load here? Okay, so load will be this, because in AC analysis this will be ground. Okay, so 3 kilo ohm and 3 kilo ohm will be in parallel, because this is ground, this is also ground, and all the capacitance will be short circuit. So we get 3 parallel 3 here, and you know that R pi is written as beta by gm, right? So you get minus gm into 3 parallel 3, right? So what is the equivalent resistance? Minus gm into 3 into 3, 3 plus 3, which is 9 by 6. So it will be 1.5. Okay, what is the value of gm? You can calculate it, because in the question IC you have already calculated, which is you know that IC by VT. From IC by VT you have already calculated this quiescent current, which is a DC current, and you just simply divided by VT, which is, you can take, if not given in the question, let me check. Okay, it is given. Okay, no, it is R pi. So you can take 26 millivolt or 25 millivolt, whatever you want. And yes, you can put the value of IC, VT. IC is what? 1 milliampere. VT is what? 25 millivolt. IE into 1.5 kilo ohm, right? So when you calculate this, it will be equal to 60, but it will be in minus 60. So the correct answer of this question is this, D. So the mid-band voltage gain of this amplifier is minus 60. If you like this video, please like, share and subscribe my channel. Thank you.